Hello students, welcome back to the channel. In the last class we have started the terms related to measurement. We have seen mean value, absolute error, uh, mean absolute error until percentage error we have seen. Okay, so now we'll go for the next topic, that is combination of errors. Okay, next we'll be seeing combination of errors. Let us first understand what is the meaning of combination of errors. So generally when we measure any physical quantity, most of the time it may depend, or it does depend on several other physical quantities. For example, if you want to measure the area of a rectangle, area of the rectangle is length into breadth. So first we have to measure the length of the rectangle, then you have to measure the breadth, and then finally the area. So what happens is that we make some mistake while measuring the length of the rectangle. We make some mistake while measuring the breadth of the rectangle, and in turn because of that there will be some error in the measurement of the area. Okay, so how we find or how we relate the error in the measurement of area to that in the measurement of the error in the measurement of length and breadth is called a combination of errors. So these physical quantities can be combined with each other via various mathematical operations. So we'll see on case to case basis what is the formula that we have which relates errors in individual measurements to the final value, which is depending upon those individual measurements. Okay, so the name of the topic is combination combination of errors. Okay, so first one that we are going to see is sum or difference. Okay, so what it means is, suppose if you are combining two physical quantities which are related to each other via mathematical operation addition or subtraction. Okay, so let us take two physical quantities. Suppose the first quantity we take it as capital A, and that we can represent as A plus or minus delta A. So here A could be the true value or the mean value, and delta A is the error value. And then we have, suppose B, which can be written as small b plus or minus delta B. Okay, so first we'll see for the sum. Okay. What will be the error if a certain physical quantity is sum of A and B? Okay. So suppose if you write Z, which is equal to A plus B. Fine. So now we can write the final value Z as a small z plus or minus delta Z. So here Z is the true value, delta Z we can take it as the error Z, and that will be equal to small a plus or minus delta A plus, this is just for capital A part, and for B we can write it as small b plus or minus delta B. Okay, now true value of Z will be equal to the sum of true value of A and true value of B. So plus or minus delta z. Here if we rearrange a little, we can write it as a plus b plus or minus delta a plus or minus delta d. So this a and b we can cancel. So from here the relation that we get is plus or minus delta z is equal to plus or minus delta a plus or minus delta b. Okay. So the maximum possible error that we get. Okay, so here the aim or the goal is to find out a formula for maximum possible error. So the maximum possible error that can happen when we are adding or subtracting two physical quantities is, like in this particular case, the sum, the maximum possible error. Okay, maximum possible error we are gonna get as delta z will be equal to delta a plus delta b. Okay. This will be our delta z. Clear? So like the maximum error will occur, either it could be positive error or negative error, when both the errors are positive or when both the errors are negative. In that case the maximum possible error happens. Fine. So, and finally we represent z as z plus or minus delta z, where delta z is the maximum possible error. So that means the z value will be lying somewhere between capital Z minus delta z to capital Z plus delta z. Now we get similar relations for difference also. So now I will not be doing the derivation. We'll just see the formula because the derivation is not that important. Otherwise it is going to take a lot of time. We'll focus more on the problem solving part. Now let us see the difference. Difference in the sense when two physical quantities are related to each other via subtraction. So suppose if z is a minus b. Okay. So in this case also the maximum possible error comes out as okay. So see, maximum possible error will happen like for example in this case also actually the maximum possible error is the sum of the errors. The magnitude of the maximum possible error will be delta a plus delta b. Okay. So how we are getting this to understand logically. So the error in a and b, they can be either positive or negative. Yes or no? So the error in the combination will be maximum when error in a is positive, okay, but that in b is negative. So in that case this negative and negative will become positive and we are going to get delta a plus delta b again. So I hope you are understanding what is happening here. So if error in A is positive and B is negative, in that case the error comes out as delta A plus delta B. And if it is the other way around, if error in A is minus delta A and in error is B is positive, in that case the overall error will be minus delta A minus delta B. So magnitude wise the maximum possible error in this case also is delta A plus delta B itself. Okay. So I hope you are understanding the point. Now let us go for other combinations. So we'll just see the formulas quickly. So the second one is multiplication and division. Okay. If the two physical quantities are related or linked to each other via multiplication, let's not put or, let's take not and, let us put or here. Okay. Multiplication, what happens, suppose if z is equal to a into b. Okay. If z is related to a and b via multiplication, so a is same, small a plus or minus delta a, and b is small a plus or minus delta b. Okay. So now here on what happens is that when we are deriving the relation, we are doing certain approximation in the sense we are ignoring small values. Okay. So if z is a into b, upon derivation the result that we get for the maximum possible error case. Okay. The relation is delta z by z. Okay. We can write it as delta z by z is equal to delta a by a plus delta b by b. This is the relation between the maximum possible error in a, b and z. Okay. Similarly, if we see the division relation, for division also the formula is similar. Okay. So if we have division, okay, so here delta a, I hope the terms are self explanatory. Delta a is error in a and small a is the true value. Similarly, delta b is error in b and small b is the true value. So these values or these formulas we are getting with the help of certain approximations that we are doing. Okay. And the final result is important. So if you have a division relation, if z is a by b, in that case we can write delta z by z. So in that case also, again, the formula that we are looking for is for maximum possible error. Okay. Maximum possible error. Okay. So the relation is delta z by z is equal to delta a by a plus delta b by b. This is the relation. Fine. Now if you go for exponential relation or like quantities raised to power, For example, if you take z equal to some a square like that. Okay. So if we have z equal to a square, we can write it as capital A into capital A again 2 times. So if we use the multiplication relation, okay, we are looking for maximum possible error. Okay, what are we looking for? Maximum possible error. So in this case, again, what we're going to get is delta z by z will be equal to delta a by a plus delta a by a. So here both a and b are same as a, so we can see that it will come out as delta z by z becomes 2 times delta a by. Okay. Similarly, instead of the power raised to 2, if we had a power raised to 4, suppose if z is equal to capital A to the power 4. Okay. So in that case, the maximum possible error that we have is, this case, delta z by z will be equal to 4 times delta a by a. Okay. Fine. So now the most important formula that we have, the general relation, the general relation, general, the general relation we'll see. So general relation or general expression, if we write. Okay, so what we have, suppose if we have z equal to a to the power m, b to the power n divided by c to the power p, or this will take some different expression. Suppose q, certain quantity q is a to the power x, b to the power y by c to the power z. So it's basically the same formula. I'm just using different terms to keep it simple. Okay. So now the error in q, the relative error, okay, delta q by q, that is the error in q by the true value q, will be equal to x times delta a by a. Okay. Now let's keep in mind here that this is also the formula for maximum possible error case. Okay. This expression, this relation is for maximum possible error. Okay. So delta q by q will be x times delta a by a plus y times delta b by b and z times delta c by c. Okay. Fine. So this is the formula that you need to keep in mind. Now you can see that these are relations for a relative error, like delta q by q is This is relative error. Okay. Most of the time in the question they ask us to find the percentage error. So percentage error will be delta Q by Q. Just a moment. Okay, so what I was saying is that delta Q by Q here is a relative error. Okay, and if you need to find percentage error, then you have to multiply both sides by 100. Okay, so delta Q by Q into 100 is going to be your percentage error. Okay, now there is a very important point, okay, that these combination of error formulas, okay, the above approximated formulas are valid only for errors less than 5%. Okay, the above approximated formulas are valid for errors less than or equal to 5%. Okay, so this is a very important point that you need to keep in mind. Okay, now let us see some questions, and we will wind up this session. Couple of questions we'll see. Okay, let us see this question, which is based on the topic that we just studied. Okay, fine. So here the question says, if the error in the measurement of radius of a sphere is 2%, then the error in the determination of volume of the sphere will be. Okay, so here an important point is that uh, valid for individual errors in the sense, if a particular physical quantity is depending upon more than 2 3 quantities, then those quantities on which it is depending, they should not have error more than 5%. Okay, so overall your final result value, in the overall final result value, the error can be more than 5%, that is fine, but the individual errors, the physical quantities which are getting combined to form that final derived quantity, in those the error should not be more than 5%. In that case, we will not be able to use the above formula. Okay, now let us see here. They are saying, if the error in the measurement of radius of a sphere is 2%, then the error in the determination of volume of the sphere will be. Okay, so see, the volume of a sphere formula is 4 by 3 pi r cube. Okay, what is the formula for the volume of a sphere? 4 by 3 pi r cube. So this is based on the approximation of error concept. Now here 4 by 3 pi are constant, so there will not be any error in this. So these constants we ignore while calculating the percentage error. Okay, so we can write delta v by v. Delta v by v here will be equal to 3 times delta r by r, because it is related to the third power of the radius. Okay, here in this 4 by 3 pi there will not be any error, so we are ignoring that. Now the relative error in the volume will be 3 times the relative error in the radius. So now if you multiply both sides by 100, delta v by v into 100 will be equal to 3 times delta r by r into 100. Okay, so this delta r by r into 100 is basically the error in the measurement of radius, which they have given as 2%. Okay, so the error in the determination of volume, the percentage error, that is delta v by v into 100, that is going to be 3 into 2%, that will be 6%. Okay, that will be the answer here. Okay, so the required error will be 6%. Okay, now like from the same data they could have asked the percentage error in the determination of surface area. So surface area formula we know, surface area of a sphere is 4 pi r square. Okay, again 4 pi is a constant here, so in this case we can write delta a by a as 2 times delta r by r. Okay, now if you multiply both sides by 100, we'll get delta a by a is equal to 2 times delta r by r into 100. Okay, so this delta r by r into 100 is basically the percentage error in the measurement of radius. So if you multiply both sides by 100, which will be basically equal to, so I have already multiplied here. Okay, so in the step itself we had to multiply actually. Sorry. Yeah, so this is basically the percentage error in the measurement of area, so that will be 2 times 2%, and that comes out as 4%. Okay, so the error in the measurement of area will be 4%. Okay, I hope this is clear. Now last thing that we'll do is we'll find the error. We'll see one previous JEE Mains problem, one last question, and then we'll wind this up. Okay, so you can see again a question directly based on the error approximation formula. They have given Z is a physical quantity, okay, which depends on A, B, C and D. Z is a square b to the power 2 by 3 and root c means it is the power of c is 1 by 2 into d cube. So that's the relation. Now the percentage error in the measurement of ABCD they have given, we need to find the percentage error in Z. Okay, so here we can write this as delta Z by Z will be 2 times delta A by A plus 2 by 3 times delta B by B plus 1 by 2 times delta C by C plus 3 times delta D by D. This is the thing. Okay, now if you multiply both sides by 100, so that is delta Z by Z into 100 will be let me create a little bit more space here. So that will be 2 times delta A by A into 100 plus 2 by 3 times delta B by B into 100 plus half times delta C by C into 100 and plus 3 times delta D by D, again little bit of space crunch we have, into 100. So now you can understand, basically we need to put the individual percentage errors and simplify. So it becomes 2 into 2% plus 2 by 3 into, in B they have given an error of 1.5%, which can be written as 3 by 2% plus 1 by 2 times the error in measurement of C is 4% plus 3 times error in measurement of D, that is 2.5%. Okay. So this will come out to be, this gets cancelled, so 4% plus 1% plus 2% plus 7.5%. Okay. So how much will that come out to be? So that is 7 plus 7.5, that is 14.5%. So that will be the answer. Okay. So answer for this particular question is 14.5%. Okay. Okay, students, I hope this is clear, and I'll end the session now. We'll see some more problems, and we'll see the. So in this question, there actually were options which I did not write. So options were 12.25%. Second, you have 16.5%. Third, you have 13.5%. Fourth one is 14.5%. So clearly we can see the answer will be the fourth option, which is 14.5%. Okay, yeah. So now in the next class, we'll try to see some more problems, or the best way we will start with the significant figures concept and the arithmetic operations on significant figures and the rounding off. Those two topics will finish in the next video. Okay, so until then, keep practicing questions based on this. Okay, see you in the next video. Chalo, bye bye.